I'm going to let you figure out how we find an inverse function. Okay? I'm going to give you a couple of examples. Actually, all you really need is one. Is that okay? I'm going to give you one example. I'm going to let you figure out the definition of how to find an inverse function. Okay? So let's start with this. 2, 6, 3, 1, 4, negative 7, and negative 2, 8. So that's a set of ordered pairs, right? Let's see if you remember some Algebra 1. Is that a function or not? It is a function. How do you know that? You're on the right. You're on the right track. Can I help you a little bit with your vocabulary? Okay. So there's two ways that we can say it. The way I think you were trying to say it is that it passes the vertical line test. Another way that we can say it is that no x's repeat. Okay? No x's repeat, so this is a function. That was just a little reminder of Algebra 1 since we're here. Okay? So if this is a function, I'm going to go ahead and teach you some notation while we're at it. Okay? I'm going to say this is the function, which we can call f of x, right? Here's the inverse function, which we're going to call f negative 1 of x. That's the notation to find the inverse function. I don't even have to say find the inverse function. I could just say f negative 1 of x equals. And you know now that means find the inverse function. Okay? So let me show you what the inverse function is, and then you're going to tell me how I did it. Kind of. How do I find an inverse function? So we're going to write this down. How do we find the inverse function? And how did you say we find it? Switch x and y. Is it really as easy as that? Most of the time, yes. Okay. With ordered pairs, yes it is. All we do is switch x and y and write it down. That's it. Okay? Any questions about that? So what happens if I give you an equation? What if I say y equals 2x plus 6? How do I find the inverse function? Well, how do you find the inverse function? Switch x and y. If I switch x and y, now it looks like x equals 2y plus 6. Now, that's not a wrong answer, but it's not a complete answer. Okay? I do. I need it. Well, not standard necessarily, but I need to get it into like a regular form that I'm used to, right? I need it to really end up as y equals, right? I need it to end up as y equals, okay? Well, in order to get this equation into y equals, the first easiest step would be what? Subtract 6 from both sides. X minus 6 equals 2y. Divide by 2. Now, there's like 14 different ways we can write this answer. Are you okay with that? I could just write x minus 6 over 2 like I have right here. That's not wrong. I could write x over 2 minus 3. I could write 1/2 x minus 3. 1/2 x minus 6 over 2. Do you see all the different possibilities? So is it okay if I just leave it like this? Okay. You guys are smart enough to be able to figure those out, yes? Okay. So if this is the function, wait, can I say that's a function? What shape is that? If I graphed it, what shape is it? Is it a line? So is a line a function? Are all lines functions? No. Which ones are not functions? vertical lines, right? Vertical lines are not functions, okay? But is this a vertical line? No, so is this a function? Yes. Is this the inverse? Yes. Is it an inverse function? You could. What shape is it? It's a line. Is it a vertical line? Then it's a function. Okay? Now we're going to come back to this problem in just a minute, but I need to teach you some other things first. Okay? But like I said, I'm leaving this space open right here because we're going to come back to it in just a second. Okay? Is this a function? Okay. Just going to give myself a little notation right there. Okay. How do I find the inverse? Switch x and y. So x equals y squared minus 4. What do I have to do first? I have to add 4 first. Okay. In some of these situations, on this one, I didn't have to subtract 6 first. I could have divided every single thing by 2 first, but that would have been messy. So that's why I said this was the easiest thing to do first, right? Here I have to add 4 first because I can't start square rooting stuff until that's by itself, right? So if I have x plus 4 here equals y squared, then I can undo this squared. How do you undo a squared? The square root, okay? So the square root of x plus 4 equals y. Is that a function? In order to know that, you got to remember what square roots look like. Right? Quadratic looks like a parabola. What's a square root look like? Nope. It's like half a parabola. So it's like starts here and goes up to the side. You remember that? So is that a function? Okay. Guys, we're going to put these in the calculator in just a minute, but we gotta go on. I need to get somewhere first. You okay with that? Okay. So are you comfortable? Could you do this problem if this was a 3 instead? What would you have done right here? Cube root, right? You'd cube rooted both sides. So here's the thing. Hopefully you realized at some point that squared functions like quadratics and square root functions were related. Well, they are. How are they related? They're inverses of each other. Well, if this was a 3, I would have gotten a cube root right here, right? Well, how are cubes and cube roots related? They're inverses of each other. Okay? That's how you know in order to undo a square, you have to do a square root because those are inverse functions of each other. Okay? I'm going to show you in a minute how more closely related they are that you don't even realize. But I need to show you one thing first. Okay? I need to show you how to verify that two things are inverses of each other. Okay? And this is an important skill to have. Okay? First of all, yes, we need to know how to do it for now in this very, very point in time in our life. But in pre-calculus, you definitely need to know how to do inverse functions. Okay? And especially verifying inverse functions, how I'm going to show you how to do it. Let me give you some example, or let me give you some problems so we can talk about it. Okay? Here's the first problem I want you to do. I want you to verify that these are inverses of each other. We are not going to take this, switch x and y and solve for y, and then take this x and y and solve for y. There's a different way we're going to do it, and it's called composition of functions. If you ask somebody in pre-cal or calculus right now about composition of functions, they may or may not know what you're talking about. But if you ask them about Fogg and Goff, they'll know exactly what you're talking about. Okay? Here's what composition of functions is. First of all, if I tell you f of x, you know what that means, right? That's function notation, right? What if I ask you to find f of 2? What does that mean? So I want to put 2 where there is an x, right? So what if I ask for f of g of x? The whole g anywhere there's an x, right? So I start with f. Well, f is x plus 6, right? But instead of anywhere there's an x, I'm going to put a g of x. Do we know g of x? X minus 6. So I want to put that right there. X minus 6. You okay with that? Can you simplify that any? Yeah. Just x, because negative 6 and positive 6 is just x, right? Well, that's the first part, is doing f of g of x. What do you think the second part is? G of f of x. That means I start with g, and g is x minus 6. And instead of x, I put f of x. Except I know that f of x is x plus 6. So I put that there instead. Can I simplify that? X. So what I've just done is I've just verified that these two are inverses of each other. Because when I did f of g of x and g of f of x, I got x. Guys, it's not even enough that I got the same thing. They have to both be x. I'll show you why in a second. You just have to wait for me. Is that fair? Okay. So, I said a second ago that a pre-cal or calculus student would know that this was called Fogg and Goff, right? Well, here's why they would know it's called Fogg and Goff. Because you don't always write it like this. Sometimes you write it like this. We're not there yet. We'll get there. Fogg and Goff. That's not a 0, and it's not really a multiplication sign. It's like of, almost, maybe. Okay, f of g of x and g of f of x. So do you see why they would call it Fogg and Goff? Okay, this is for us to use to verify things are inverses of each other. Fogg and Goff. So if I say verify these two functions are inverses of each other, you're using Fogg and Goff. Okay? What do Fogg and Goff have to equal for you to actually verify that they're inverses? X, right? So what if I do Fogg and I get 2x? Not only are they not inverses, you stop. You don't have to do g of x, do you? Okay? You can just stop because you already know one of them's not x, the other one's clearly not going to be x, or even if it is, it doesn't matter. Okay? Because they both of these have to be x for them to be inverses. Okay? You okay with that? So here's what I want to show you. Remember I told you we'd be coming back to this other problem? Let's go back to this other problem. I'm going to show you something on the calculator. I'm going to zoom in so you can see the screen. You guys have your notes so you can look at the equations, right? Okay. First thing I want to put in the calculator is the first equation I used. 2x plus 6. Okay. The second equation I want to put in the calculator is the second equation that I got, the inverse of that function. Okay? So I'm going to put in x minus 6 over 2. Now that's interesting, right? If I verified that these two functions right here, you can't see that I'm pointing to, these two functions right here are inverses of each other, what would I get? X, right? I know they're inverses of each other, first of all, because I did it. We did all the work correctly. But if I ask you to verify the inverse functions, or that they were inverse functions, you would get Fogg and Goff both to equal x. So that's the third equation I'm going to put in here. So first of all, where do these two lines, the red and the blue line, if you can tell the colors, where do they meet? Not specifically, more in general. on that line, right? Don't they meet on the line y equals x? Isn't that exactly where they cross each other? Guys, does that make any sense? I hope it makes a lot of sense. How did you find an inverse function? We switched x and y, we made y equal x, and we made x equal y. So does it make sense that these two lines should cross on the line y equals x? Now, let's use our imagination here for a second. If I took this calculator, which I cannot, okay? Well, I mean, I can, I just don't want to embarrass anyone. And I folded the screen in half. I really can't do that, I was just teasing, okay? But I folded it right along the line y equals x. If I folded it up, what would be true about the red line and the blue line? They would be on top of each other. Because every x on this line is a y on this line. And every y on this line is an x on this line. Y equals x. So what line do inverse functions reflect across? Y equals x, right? So if I ask you to graph two functions to prove that they were inverses of each other, you'd really have to graph three, wouldn't you? The two functions I gave you and y equals x. Does that make sense? So that's why, let me zoom out just a little bit. That's why I wanted the space so I could put the calculator here so I could show you that. I mean, you can graph it if you want, so that's probably a good idea so we have it in our notes. So we have this. We have the line y equals x. I'm going to draw the line y equals x as a dotted line because it's not really part of our problems per se. Okay. And then I have this line y 2x plus 6. And that's like right here. Y equals 2x plus 6. And then I have the line, this other line right here. And it goes like this. Y equals x minus 6 over 2. They meet right along the line y equals x. Okay? Any questions about that? Now, this one's, I want to do the same thing, but it's different. It's a little different. Okay? Let me zoom in again so you can see the calculator better. You have the equations you can look at. I'm going to leave y equals x alone. I'm going to clear that one. And I'm going to clear, not that, that one. No, I said clear it. Escape. Okay, I'll delete. That's fine. So this is x squared minus 4. Is that what we expected x squared minus 4 to look like? Yes, it's a parabola that moved down 4, right? Now, if I'm thinking about this ahead of time, I'm switching x and y and solving for y, or I'm thinking about how this is going to reflect over this way, it looks like it's going to have to be like this, right? Something like that. So if I tab and go up to F2 and I put in the square root of x plus 4, that's not what happens, is it? But if I folded this line, folded it along this line, and only looked at this side of the parabola, so like that side of the parabola is not there, would those be inverse functions? So what happened? Why does it look like we wanted it to look, like we thought it would look? They're a different type. We know they're inverses of each other, right? Okay. Why doesn't a square root function have a bottom half? Then it wouldn't be a function, would it? If it had this and this, it's not a function, is it? So we only have the top half. So when we're trying to figure out, or to just think about what this would look like if I, seriously calculator, my goodness. If I, trying to figure out what it would look like if I folded it, first of all, does it meet on the line y equals x? Yeah, right there. This side of the parabola is not reflected though, okay? Because that would make this square root function, not a function anymore. Okay, so a lot of times when you look at things on a worksheet or something, or in your book, if you're trying to graph these, it's going to say, here's the function, but we're only talking about the stuff greater than 0. It's going to give you a restriction on your domain. Does that make sense? Okay. Let me give you your worksheets. Okay, here are your worksheets. Please circle the following problems. Thank you. There it is. Okay, on this worksheet, please circle the following problems. Please circle number 1. Please circle number 7, 11, and 15. So we already circled 1, 7, 11, and 15. Please circle number 20 and 23. And on the back, please circle 25 and 27. Okay? Those are the problems that I would like you to do for homework today. Do you have any questions?